Now we are going to see about clustering around medoids. The first one, neighbor choosing representative neighbors. Imagine you have a bunch of friends and you want to split them into smaller groups based on how similar they are. In this method, you start by picking certain friends to be the leaders of each group. These leaders are like the captain or representative of their groups, and we call them medoids. Next one, neighbor assigning friends to group's neighbor. That is, next each friend is assigned to the group of the medoid they are most similar to. For example, if your friend is most like the medoid who loves sports, they will join that groups. We decide similarity based on things like how close they live, their favorite activities, etc. Next, neighbor evaluating groupings neighbor. After everyone is in a group, we check how well the groups are made. We see if the friends in each group are very similar to each other and if they are different from friends in other groups. We want each group to have friends who are very much alike. Next one is neighbor updating medoid's neighbor. That is, updating the group leaders. Sometimes we might need to change the group leaders or medoids to make the groups better. We pick new leaders who represent their groups even more accurately. For example, if the current leader of the sports group moves away, we might choose someone else who is also really into sports. The last one is neighbor iterating for better result neighbors. That means trying again for better groups. We might do this process a few times until we are happy with the groups. Each time we try to make the groups more similar on the inside and more different from each other. It's like rearranging puzzles pieces until they fit just right. So, clustering around medoids is like organizing your friends into groups based on who they are most similar to, but with the extra step of choosing leaders for each group to make the process smoother. Next one is cell outing. We have a data set with items grouped into two clusters, A and B. Here, how we can calculate this load score for one item in the data set. So the first we can calculate neighbor calculates average intra-neighbor cluster distance neighbor. That is neighbor for an item in cluster A. Find the average distance from that item to all other items in cluster A. Neighbor, this gives us the average intra-neighbor cluster distance A. The second one we have to find neighbor calculate nearest cluster average distance B neighbor. So for that we have to take neighbor, find the nearest neighboring cluster to cluster A. Let us say it's cluster B. Neighbor calculate the average distance from the items in cluster A to all items in cluster B. Neighbor, this gives us the nearest cluster average distance B. Then finally we have to calculate Silhouette score neighbor. Neighbors subtract the average intra-neighbor cluster distance A from the nearest cluster average distance B. Neighbor divided the result by the maximum of the two distance maximum of A, B. Neighbors, this gives us the Silhouette score for items. We repeat this process for all items in the dataset and calculate the average Silhouette score for the entire dataset.